Scientists have now verified what many believed could never happen. Under the streets of Naples, Italy, a 9-kilometer subterranean magma corridor has physically joined two of the most hazardous volcanoes on Earth, Campi Flegrei and Mount Vesuvius. The same Vesuvius that entombed an entire city in ash. The same Campi Flegrei that nearly erased human life across Europe 39,000 years ago. Now connected, now sharing pressure, now functioning as a single system. And the warning scientists are issuing today is unlike anything stated in modern volcanic history. If one erupts, the other may follow. It began on March 13, 2025. At 3:42 a.m., a powerful earthquake split the ground beneath Pozzuoli. Within minutes, emergency lines were overwhelmed with 847 calls. Residents described steam blasting from fresh cracks in roads, basements, and parking structures. This was no burst pipe or gas leak. The fractures traced a defined fault line descending 9 kilometers into the earth, pointing straight toward Mount Vesuvius. Then came the revelation that changed everything. Researchers at Stanford University processed the seismic recordings using advanced artificial intelligence. What emerged stunned the scientific world. Hidden within that single quake were 54,000 microtremors conventional instruments had completely failed to detect. The caldera wasn't merely shaking, it was fragmenting from the inside, and the pressure wasn't contained. It was migrating through a newly formed underground passage, streaming directly toward Vesuvius. Within 48 hours, Vesuvius registered deep tremors for the first time since 1944. Long silent steam vents reactivated across both volcanoes simultaneously. Gas chemistry shifted. Deep magmatic sulfur began rising toward the surface. The link wasn't just proven, it was widening and heating by the day. Right now, 3.5 million people live between these two volcanoes. Evacuation strategies were built for a single eruption scenario, never for two at once. And the question now haunting volcanologists, emergency officials, and every resident of Naples is simple. Are we already too late? March 13, 2025, 3:42 a.m. A magnitude 4.4 earthquake strikes the Campi Flegrei caldera without warning, the strongest recorded there in over 40 years. In Pozzuoli, home to 80,000 people directly above the caldera, residents are jolted awake by violent shaking. Furniture crashes across floors. Windows shatter. Frames fall from walls. Car alarms scream through the darkness across entire districts at once. Families rush into the streets in nightclothes, frightened, confused, searching for answers that don't yet exist. Within minutes, 847 emergency calls report the same phenomenon. Steam forcing its way through new fractures that appeared overnight in streets, basements, and parking areas. The cracks aren't random. They align precisely along a single fault cutting through the city like a scar, a fault plunging 9 kilometers deep and pointing directly toward Mount Vesuvius. But the greatest shock isn't the shaking itself. It's what scientists uncover inside it. Stanford researchers immediately analyzed the seismic data with cutting-edge AI systems. The findings are chilling. The system detects 54,000 microtremors embedded within the quake's signature. Tremors so subtle and rapid that every standard seismograph missed them. This isn't the fingerprint of one earthquake, releasing pressure and settling. It's the signature of a system splintering internally. The caldera isn't reacting to a single event. It's breaking apart in thousands of invisible fractures at once. The analysis traces the direction of those seismic ripples. Data reveals that the quake opened a deep conduit stretching 9 kilometers underground. And that conduit isn't dormant. It's actively channeling pressure waves from Campi Flegrei's Magma reservoir straight toward Vesuvius. Dr. Tatiana Ventura, a geophysicist at Stanford Earth Sciences, explains the implications plainly. The geothermal reservoir behaves like a sealed pressure vessel. Once the caprock fractures, fluid pathways form, potentially destabilizing connected volcanic systems. The seal has broken. The pressure is moving. Alerts are sent immediately to monitoring stations across Europe. Italian officials contact emergency management teams in Rome within hours. Scientists who spent decades studying these volcanoes as separate systems are forced to face a reality their models never considered. This isn't routine seismic unrest that will fade away. This isn't isolated activity beneath a single restless caldera. In the early hours of March 13th, geology textbooks were rewritten. A single earthquake physically connected Europe's most dangerous supervolcano with the mountain that destroyed Pompeii. Two systems once believed independent are now behaving as one. And the mounting pressure has only one direction to go: upward. To understand why this date terrified scientists worldwide, you must understand what lies beneath Naples. Not a classic cone-shaped volcano, not a single crater, something far more complex and far more dangerous. Campi Flegrei, meaning burning fields, stretches roughly 8 miles across just west of Naples. It represents 600,000 years of violent eruptions that have repeatedly reshaped Italy's landscape. 3 million people live directly above it today, most unaware of what rests beneath their feet. Its destructive legacy traces back to two catastrophic events. 39,000 years ago, the Campanian ignimbrite eruption expelled around 200 cubic kilometers of volcanic material in one apocalyptic blast. Imagine a wall of superheated ash and rock racing at 300 miles per hour across the Italian peninsula. Eastern Europe was buried in debris. Global climate patterns shifted for years. Entire species vanished. Human populations across Europe nearly collapsed. Campi Flegrei didn't just alter geography. It nearly ended a chapter of human existence. 15,000 years ago, the Neapolitan yellow tuff eruption unleashed another 200 cubic kilometers of material, carving out the massive caldera that now underlies one of Europe's most densely populated regions. Unlike a cone volcano that concentrates pressure in one visible peak, Campi Flegrei operates as an interconnected pressure network. Magma chambers lie 3 to 8 kilometers beneath the surface. Pressure in one chamber influences the others instantly. Beneath Pozzuoli lies a labyrinth of magma and fluid conduits balanced in delicate instability. When one segment shifts, consequences ripple outward unpredictably. This isn't simply a mountain that might explode. It's a pressure system that could collapse. Warning signs have been visible for decades. As magma and hydrothermal fluids push upward, the ground rises, a process known as bradysism. Since 1950, the caldera floor has lifted 4.3 meters. What alarms scientists most isn't the total rise, but the acceleration. Uplift rates now reach 2 centimeters per month, a 340% increase compared to earlier unrest cycles. NASA's satellite data confirms the swelling trend continues in one direction. Then comes seismic escalation. Between 1982 and 1984, Campi Flegrei produced 16,000 earthquakes over 2 years. Buildings cracked, walls collapsed, families abandoned homes, sleeping in cars out of fear. Tens of thousands were evacuated from Pozzuoli. Gas emissions add another threat. Fumaroles and mud pools release carbon dioxide, sulfur dioxide, and hydrogen sulfide into the air. Residents describe a suffocating stench like rotten eggs mixed with burning chemicals. Headaches, nausea, and burning eyes follow. At high concentrations, the gases are deadly. Thermal activity is the final warning stage. Ground temperatures spike in scattered zones, hot enough in some areas to cook an egg on bare rock. Heat seeps upward through soil and pavement into the foundations of homes. For unrest cycles since 1950, for escalating warnings, each stronger than the last. Scientists analyzed every tremor and gas sample, assuming one isolated volcano. That assumption became the most dangerous oversight in modern volcanology. Within 48 hours of the March rupture, evidence became undeniable. Monitoring stations along the new fault recorded temperature spikes of 12 degrees Celsius. Magmatic fluids were moving, crossing from one volcanic system into another. Steam emissions surged across both Campi Flegrei and Mount Vesuvius within the same 48-hour period. Vent output jumped 340%. Dormant vents roared back to life, sending plumes visible across Naples. Residents watched both skies change simultaneously. Gas analysis confirmed deep magmatic sulfur compounds in the steam, unmistakable evidence of magma rising from depth. The chemistry had shifted dramatically. Then Vesuvius stirred. For the first time since its 1944 eruption, deep seismic signals emerged from its magma chamber. Not shallow rock shifts, but pressure waves generated from within. The mountain that buried Pompeii was awakening, directly in response to what was unfolding 9 kilometers away beneath Campi Flegrei. Thermal scans soon exposed the most unsettling development yet. The subterranean passage was not settling down. It was growing. Steam pressure was actively cracking more bedrock along the entire route. Each time another section of rock failed, seismic readings surged again. The link between the two volcanic systems was not a fixed fracture locked in place. It was a dynamic, expanding structure, widening faster than scientists could accurately simulate. Seismic tomography provided the essential geological context. A massive magma reservoir stretches beneath the entire Campanian volcanic arc at depths of 8 to 10 kilometers. This body connects systems researchers had spent entire careers examining, as if they were completely separate. The March 2025 rupture did not create a new feature. It reopened something ancient. Pathways that had taken thousands of years to seal were reactivated in a matter of days. The two volcanoes were once again sharing pressure, heat, and a future no modern framework had prepared anyone to confront. The figures are overwhelming, and they do not become easier to comprehend with repetition. Right now, 3.5 million people live in the Naples metropolitan area. Each morning, every one of them wakes beneath the looming presence of a reawakened supervolcanic system. They sip their coffee. They send their children to school. They walk streets they have known all their lives. Yet beneath those streets, the ground trembles more frequently. Fresh cracks appear in walls that stood intact the night before, and the scent of sulfur drifts through open windows from vents that did not exist a year ago. The emergency strategies designed to safeguard these 3.5 million residents were built around a single premise: one volcano at a time. Italian evacuation protocols were structured to address either Campi Flegrei or Mount Vesuvius as isolated threats, each with its own safety zone, warning schedule, and escape direction. Those strategies reflected decades of meticulous planning. They are now perilously insufficient. The geography itself compounds the crisis. Roads leading away from Campi Flegrei do not open toward clear safety. They funnel toward Vesuvius. Evacuation routes overlap, conflict, and compete for the same limited space. Traffic simulations show highways across Naples would gridlock within hours if simultaneous evacuation orders were issued. Communication networks would strain under the weight of 3.5 million people trying to call, text, and navigate at once. National emergency resources would be stretched beyond capacity before the first evacuees reached secure ground. Conditions on the ground provide little reassurance. Steam vents are appearing across Pozzuoli almost daily. Roads warp and fracture as the earth shifts below the asphalt. Buildings display new structural cracks each morning that were absent the night before. Residents are no longer startled by tremors. They have woven them into daily life, perhaps the most chilling detail of all. The threat extends far beyond city boundaries. Atmospheric projections indicate that a joint eruption of both systems could blanket much of southern Europe in ash within days. Flights across the Mediterranean would halt. Respiratory emergencies would spike in cities hundreds of kilometers from Naples. Agricultural regions that supply food to millions across Europe could be buried under meters of ash within hours, triggering an economic shock that reverberates across the continent for years. The Italian government has elevated the alert status for both volcanoes to the highest classification. Emergency teams are working continuously to craft contingency plans for a scenario unprecedented in modern history. Every hour matters because thermal readings continue to rise, tremors continue to intensify, and 3.5 million people are still waiting for answers that remain incomplete. Scientists studying the connection between Campi Flegrei and Vesuvius have begun using a phrase that unsettles emergency planners across Europe. They describe what is unfolding beneath Naples as the first domino, not the last. The Mediterranean basin does not contain just two hazardous volcanic systems. It holds dozens. Mount Etna towers over Sicily's eastern coast as Europe's most active volcano. Santorini rests in the Aegean Sea, the remnant of an eruption so immense it may have helped topple Bronze Age civilizations. Stromboli erupts with near-constant regularity off Italy's coast, earning its reputation as the lighthouse of the Mediterranean. Volcanic islands that the seafloor in numbers rarely considered. Many may share deep geological links to the same underground networks, now reactivated beneath the Campanian Arc's seismic evidence, suggests the magma source feeding Campi Flegrei and Vesuvius extends beyond their visible boundaries. It spreads outward. If pressure now moving between these systems continues to migrate through deeper channels, the implications extend far beyond Naples. Subsurface pressure does not vanish. It transfers, seeking release through any available fracture. A cascading chain of eruptions across the Mediterranean is no longer dismissed as fringe speculation. Veteran volcanologists now debate it seriously in formal scientific forums. An event of that magnitude would be without precedent in recorded human history. The last time Mediterranean volcanoes erupted in coordinated sequence, there were no cities, no infrastructure, and no millions living in blast zones, ash corridors, or pyroclastic paths. Every geological example of such cascading activity predates modern civilization. There is no historical manual, no contemporary template, and no comparable case study for planners to examine. Dr. Mario Wright of the Vesuvius Observatory summarizes the reality with stark clarity. The region is confronting an entirely new paradigm of volcanic risk. The renewed link between Campi Flegrei and Vesuvius has the capacity to affect millions and dramatically alter the geography of southern Italy. Volcanologists and geophysicists from around the world are converging on the area, equipped with advanced instruments, cutting-edge models, and decades of experience. Yet they face a sobering truth. No monitoring system has ever documented two volcanic systems reconnecting in real time. Science is operating without precedent, without guarantees, and without certainty. The first domino has fallen. What follows remains unknown. Each day brings additional data. New tremors register across regional seismographs. Satellites capture images of emerging steam vents. Researchers measure fresh fissures in the streets of Pozzuoli with instruments pressed to the pavement. Monitoring stations record continuously. The metrics keep climbing. Every morning, scientists review their screens to find the situation intensified overnight. Thermal signatures are rising. Sulfur concentrations and gas emissions increase week after week. Seismic activity beneath both systems continues on an upward trajectory with no sign of leveling off. Ground uplift at Campi Flegrei remains at 2 centimeters per month, a rate 340% higher than any previous unrest period. These are not minor variations within normal limits. They are instruments pointing in one unmistakable direction. Researchers are focused on 4 critical indicators. The first is acceleration in ground uplift, not just the current figure, but whether it is increasing faster over time. The second is the depth and chemical makeup of gas emissions. The shift toward deep magmatic sulfur signatures following the March rupture was among the most alarming chemical signals recorded, and concentrations continue to climb. The third is the frequency and depth of seismic events beneath Vesuvius. Deep tremors, recorded for the first time since 1944, provided compelling evidence of shared pressure. Each new event reinforces that the connection remains active and strengthening. The fourth is the continued expansion of a 9-kilometer corridor itself. Thermal imaging shows it widening, deepening, and heating further. It has not stabilized. It has not slowed. It is unfolding. The forces moving beneath the surface obey physical laws that cannot be bargained with, postponed, or persuaded. Pressure accumulates until it breaks free. Heat climbs until it reaches open air. Broken rock does not mend itself on a human schedule. The geological mechanisms now active under southern Italy do not consider evacuation plans, political timelines, or academic arguments. They proceed on their own terms, at their own speed, toward their own outcome. Within the scientific community, a quiet but significant shift has taken place in how the situation is discussed. The question is no longer if an eruption will happen. The data has pushed that uncertainty aside. The conversation now revolves entirely around magnitude. Will the eruption remain limited to the Naples metropolitan region, devastating, yet geographically contained? Or will the pressure moving through linked subterranean systems ignite a chain reaction that extends well beyond Italy's borders? History provides the only comparisons available, and none offer reassurance. Instruments continue to log data. The underground corridor continues to widen. The answer is forming roughly 9 kilometers below ground, and it moves closer with each passing day. The earth beneath Pozzuoli is warmer today than it was yesterday. The passage linking Campi Flegrei and Vesuvius is broader today than it was last week. Tremors occur more often today than they did last month. Every dataset, every satellite scan, every gas emission reading, and every seismic trace signals the same trajectory. The system is not settling. It is intensifying. What occurred on March 13, 2025 was more than a seismic episode. It marked a decisive shift. For millennia, two of Earth's most formidable volcanic systems accumulated stress independently, erupted independently, and were researched and prepared for as separate threats. In a single morning, that division vanished. Ancient barriers that had taken thousands of years to close were reopened in mere hours. The subterranean connection long dismissed as impossible was identified, charted, and verified. Pressure that once belonged to two isolated reservoirs now circulates between them as a single unified system. 3.5 million people now live within that new reality. They feel the vibrations beneath their streets. They catch the scent of sulfur in the air. They watch fractures in buildings stretch longer week after week. They understand, in the way only those living atop something ancient and volatile can, that the systems below have rejoined, and that whatever follows will not seek approval. Researchers remain vigilant. Emergency officials refine response strategies. Governments elevate alert levels and design evacuation plans for scenarios never before executed in modern times. Volcanologists who spent their careers modeling these systems now face the sobering truth that previous assumptions may no longer hold. The caldera that once erupted with enough power to nearly devastate Europe is building toward an unknown threshold. The volcano that entombed Pompeii is reacting. The channel connecting them grows broader, hotter, and more dynamic each day. Only one question remains, the one every monitoring station, every scientist, and every resident of Naples now confronts daily. Is the world prepared for what may be coming next?